The ground is still dark. In the shadow of tall grass, a body holds flat against the earth, completely motionless. Eyes fixed on a single point ahead. The prey is feeding, ears rotating continuously, but not fast enough. The distance closes centimeter by centimeter, no sound, no signal. Then everything drives forward in 1 second. Feet push hard into the ground. Dust rises. The jaw closes before the prey can complete a response sequence. At the riverbank, a flat water surface erupts in a strike. Without warning, the prey is pulled straight down before the sound can propagate outward. In the canopy, a spotted form leaves the branch silent, precise, without warning. Feet touch the ground. The body drops low. Eyes lock onto the target. Ahead, prey grazing. No signal registering that the distance is closing with each step. The strike lands before the prey can change direction. From the grasslands of the Serengeti to the banks of the Zambezi, from the Congo Basin to the floodplains of East Africa. This is the world where the predator never stops and the prey never fully rests. Every moment is a survival calculation, and the environment does not offer a second attempt. Beneath the dense canopy of the African savanna, light is broken into small fragments. The ground appears motionless. But within the grass and shadows, a massive body moves forward without leaving a trace. The African rock python, a predator that does not rely on speed. It does not rely on venom. Its length can reach up to 7 meters. Rely on venom. Its length can reach up to 7 meters. Muscle mass coils tightly beneath patterned skin. When the constriction closes, oxygen is cut off. There is no margin for error. There is no second attempt. On the African savanna, movement determines the order of survival. Open space forces all species to remain exposed, with no long-term cover. Herbivores move in steady rhythm with ears oriented in multiple directions and eyes scanning the ground. Reflexes must occur before danger becomes visible. A single moment of delay is enough to break formation, create gaps, and immediately become a weakness. On the opposite side, predators focus on timing. Bodies remain low, and each step of approach is precisely calculated. Distance closes rapidly, and opportunity exists for only a few seconds. When the chase ends, the outcome is already decided. On this uncovered land, speed is not a secondary advantage. It is a required condition for survival. Cheetah body structure shows a clear evolutionary direction, which is optimization for acceleration in open space. Long, slender limbs increase stride length. Low weight distribution reduces resistance during acceleration. Each running step is designed to extend contact distance and shorten ground contact time. The spine has high flexibility, allowing strong bending in each movement cycle. When the body extends stride, length reaches maximum. When it contracts, elastic force accumulates for the next stride. Running rhythm is fast and continuous, without interruption from unnecessary motion. A deep chest provides space for large lungs and a heart capable of strong blood circulation. Oxygen intake is rapid and high over short periods. Wide nostrils support gas exchange when speed increases. A small, compact head reduces air resistance and maintains body axis stability. During straight running, feet contact the ground through thick pads. Claws do not fully retract and provide improved grip during acceleration and directional change. Friction is controlled to limit slipping on dry soil or low grass. Each ground contact is decisive. The long tail functions as a movement stabilizer. When the body changes direction abruptly, the tail shifts opposite to maintain inertial balance. At high speed, this stability allows trajectory maintenance without loss of control. The tail does not generate propulsion force, but directly affects steering capability. Vision forms the foundation of the entire pursuit process. Large eyes allow long-range observation under daylight conditions. Targets can be detected from many miles across open plains. Accurate orientation determines approach timing and acceleration direction. All of these characteristics are tightly interconnected. No component operates independently. On open terrain, where small deviation leads to failure, the cheetah body structure functions as a complete speed system. The cheetah reproductive cycle is rapid but carries high risk. Gestation lasts approximately 3 months. Each litter usually includes 3 to 5 cubs. From birth, survival probability is very low due to small body size and minimal defensive capability. Newborn cubs have not opened their eyes. Vision is not yet functional. Body mass is low at approximately 0.55 pounds. Soft grey fur covers the body and blends with grass and dry soil. During the first weeks, cubs barely move and depend entirely on the selected hiding site. The first 2 months represent the most dangerous period. Survival rates decline sharply due to environmental pressure. Many predators can locate the hiding site if exposure occurs. Any small sound or unfamiliar scent increases risk. At approximately 6 months of age, cubs enter the phase of true hunting. Targets are small and fast-moving. Short pursuit attempts occur repeatedly. Approach distance remains limited, but reflexes begin to develop. Each failure adds information for the next attempt. Survival skills accumulate through repeated trials without extended rest periods. Separation from the mother occurs soon afterward. At approximately 18 months of age, young cheetahs leave the mother. There is no guidance, there is no protection. Females often remain near familiar areas. Males expand movement range and seek new space for independent activity. The early solitary phase carries high pressure. Food availability is unstable. Many hunts end without retaining prey. Other predators can arrive quickly and seize the result. High prey loss rates force repeated hunting attempts within a single day. The cycle consists of short hunts, short rest, and continuation. On open land, competition does not decrease over time. Cheetahs are active primarily during daylight. Clear light improves observation in open space. This timing also reduces direct competition from nocturnal predators. Selecting hunting time is part of a survival strategy rather than chance. Within the entire cheetah survival system, speed is the central factor. There is no capacity for confrontation. There is no option to retain prey long term. When risk appears, the only effective response is rapid departure. Running serves not only hunting but also defense. The role of cheetahs extends beyond individual impact. They regulate numbers of small antelope on the savanna. When this predation pressure disappears, prey populations increase rapidly and vegetation declines. This chain reaction destabilizes ecological structure. Therefore, cheetah presence reflects savanna functional condition. Where this species persists, biological cycles maintain basic balance. Where it disappears, ecosystem direction begins to shift. Over millions of years of evolution, cheetah bodies have been optimized for short-duration speed. This achievement carries clear trade-offs. Light build, low impact tolerance, limited ability to protect prey. Each advantage introduces corresponding risk. Under rapidly changing environments with shrinking habitat, pressure increases. Despite this, new generations continue to form. Cubs learn to run, learn to hunt, and learn avoidance. This inheritance chain maintains a distinctive biological legacy of the savannah. Early daylight spreads across the African savannah. Open space gradually becomes visible. Movement begins to appear across low grass. Hunts do not wait for night. They occur while ground remains cool and visibility remains long. Within the savanna predation system, many familiar species occupy prominent positions. Alongside them exists a quieter but equally effective predator, the African wild dog. This species moves in tightly coordinated groups and maintains formation throughout the hunt. Success does not rely on individual strength. It results from coordination, endurance, pursuit, and forcing targets to exhaustion. Approach phases occur continuously without rest intervals. Across wide space where visibility determines opportunity, African wild dogs maintain pressure through constant movement. They represent an important component of the savanna predation network. African wild dogs exist through collective structure. No individual operates independently for extended periods. A pack can exceed 20 individuals and moves and hunts as a unified body. Home range is very large and spans multiple terrain types within one territory. All survival decisions occur at the pack level. Body form clearly reflects this lifestyle. Lycaon pictus displays unique coat patterns that differ among individuals and enable rapid recognition during movement. Large, rounded ears stand upright and capture sound at long distance and assist heat release during sustained activity. Legs are long and the body is compact with mass around 44 to 66 pounds. This structure favors endurance running rather than short acceleration. Sensory capability plays a critical role. Hearing allows individuals to maintain contact when the pack spreads out. Calls can travel several miles across open space. Olfaction helps determine prey movement direction through wind and supports orientation before approach. Social structure within the pack is tightly organized. Only one pair holds reproductive role. Remaining individuals participate in rearing and protecting young. Food is regurgitated and shared with non-hunting members. This model maintains population stability and ensures cub development in the safest possible environment. Communication forms the foundation of coordination. African wild dogs use multiple short and distinct vocal signals. Each signal serves a specific function, from assembling formation to adjusting position. Before hunting, the pack performs brief contact sequences, including muscle touching, face licking, and circular running. These actions synchronize movement and reduce error during collective action. The entire system operates as a single unit. It does not rely on a dominant individual. It does not fragment. Within the savanna predation network, African wild dogs represent a survival strategy based on organization and precise coordination. The African savanna opens into a vast space where ecosystems overlap along natural boundaries. Dry grasslands connect with river systems, forming unstable transition zones. These are areas where many species are forced to enter environments outside their primary advantage. On dry land, lions maintain dominance through muscular strength, speed, and group coordination. Open terrain allows this species to apply direct attack strategies and territorial control. All land-based movement remains within familiar observation range. In contrast, beneath the water surface, crocodiles hold absolute advantage. Bodies adapted for ambush, powerful bite force and concealment turn water zones into high-risk areas. River entry points, low banks and bends can all become attack locations. When the boundary between land and water is blurred, advantage is no longer fixed. An individual that missteps across environments faces immediate risk. There is no absolute safe position. Each encounter is determined by terrain, timing, and momentary adaptive capacity. Within an elephant herd, structure is clearly formed and stable. The oldest female individual holds the central position during all movement activities. This order is not based on size or muscular strength. It is based on lifespan and the amount of information accumulated across many dry and wet seasons. The leading individual accurately remembers the locations of water sources, safe travel routes, and areas where risk has previously occurred. When environmental conditions change, the herd adjusts its direction along routes that have already been tested. These decisions directly affect the survival of the entire herd, especially young elephants. When a threat appears, the formation tightens immediately. Adult individuals form a protective ring, and young elephants are moved to the center. Continuous attack is not required, because presence and positioning alone create sufficient pressure on the opposing animal. Information does not disappear when an individual grows old or weak. It is maintained through repeated movements, through responses to the same situations, and through the way the entire herd adjusts behavior according to familiar signals. Survival knowledge is accumulated over long periods without interruption. This structure allows elephant herds to endure drought, food shortages, and territorial conflict. The survival of the herd does not depend on individual strength. It depends on collective memory maintained across many generations. Lions move across the savanna during unstable periods. There is no fixed formation. There is no long-term stopping point. Open space forces individuals to continuously change position to keep pace with water sources and prey. Early daylight exposes the entire landscape with no extended cover. The savanna operates through dry and wet cycles. When water recedes, hunting areas contract. When rain arrives, territory expands, but risk increases. Food becomes dispersed. Shade is limited. Each movement decision directly affects survival potential. Lions exist within a tight social structure. But not every individual remains within a stable pride. On the savanna, many lions move independently during different stages of the life cycle. Living space is extensive, and boundaries shift with dry and wet seasons. Lion presence is not limited to clearly marked territories. It extends into buffer zones, where conflict is always possible. Most young male lions experience a period outside their birth pride. After reaching maturity, they are forced to leave due to competitive pressure. Without group protection, survival depends entirely on observation, ability, and timing of movement choices. These journeys can extend for dozens or even hundreds of miles, crossing regions with varying lion density. During movement, lions continuously assess the surrounding environment. Scent marks on grass, distant roars and fresh tracks are all critical data. Olfaction allows detection of other individuals from long distance. Avoiding direct confrontation with dominant males is essential for maintaining physical condition. Each conflict consumes energy and increases injury risk. Lion appearance clearly reflects biological condition. Mane development corresponds with age and health and changes gradually over time. Individuals in good condition can maintain independent hunting ability for long periods. Weaker individuals must move continuously to find suitable opportunity. There is no fixed route. There are only decisions adjusted day by day. Lions begin activity as light levels decline. Lower temperatures make movement across the savanna easier. Lion groups leave resting sites and spread out along familiar directions. Footsteps are controlled and bodies remain low to the ground. Movement is slow and steady to limit noise. This period is the most effective time to assess the surrounding environment. From long distance, lions observe herds of hoofed animals. Prey, position, movement, direction, and herd density are recorded. At the same time, scent marks on grass and shrubs indicate territorial boundaries of other groups. This information helps avoid dangerous overlap zones. Territory recognition is required to maintain stability within the living area. When position changes are needed, lions move in small groups. Individuals maintain spacing that allows coverage of surrounding space. Formations are not always fixed. During periods of food scarcity, temporary separation can occur. Individuals later regroup when conditions improve. This flexibility reduces internal competition pressure. Hunting activity usually occurs over a short duration. Lions use burst strength and focus on slow or isolated individuals. The approach phase occupies most of the time. When distance becomes close enough, the attack is executed quickly and decisively. If unsuccessful, the hunt ends immediately to avoid additional energy loss. Energy is tightly controlled during all activities. After each unsuccessful hunt, lions rest for extended periods. Body temperature stabilizes before movement resumes. Water becomes an important anchor point. Movement routes often follow rivers and remaining pools after the wet season. All actions depend on environmental conditions. Wind direction is calculated to prevent early prey detection. Hearing registers very small movements within tall grass. When food availability declines, lions may approach carcasses left from other hunts. This is a short-term solution that helps maintain physical condition for later stages on the open savanna. Hyenas frequently appear along open movement routes. They operate in groups and gain advantage when numbers are higher. In such situations, lions do not maintain confrontation. Distance is created quickly. Retreat direction is chosen along territorial edges where conflict intensity is lower. Avoiding direct contact reduces injury and energy loss risk. Lion life does not allow prolonged stay at a single location. Routes change continuously with dry and wet seasons. When water sources shift, hoofed animals also change migration direction. Migratory lions closely follow these changes without remaining fixed in one area. Grasslands that were once abundant can become empty within weeks. Lions do not approach prides randomly. All actions depend on the condition of the male controlling the territory. When signs of weakening appear, a power gap begins to form. This is the time when other lions move closer to the territorial edge. When entering a pride area, risk increases rapidly. Defensive males remain present and respond immediately to intrusion. Conflict can occur within a short time at high intensity. Outcome depends on strength, physical condition, and timing. Mating occurs only when the female accepts and the surrounding environment contains no immediate threat. This process is brief and does not continue for long. Afterward, the lion leaves the pride area and does not remain to raise offspring. Strong genetic inheritance provides advantage from birth. Individuals with favorable genetics have higher survival probability in harsh environments. Competition among males occurs continuously and removes weaker individuals while maintaining population quality. This natural mechanism keeps lions in strong condition. During movement and range expansion, lions contribute to connecting separated groups. Gene flow is exchanged and reduces genetic degradation. On the savanna, lions frequently encounter hyenas, buffalo, and other male lion groups. Each confrontation consumes energy and carries injury risk. A troop of baboons moves across the savanna in a loosely spread formation. Distance between individuals is kept consistent to allow mutual observation. Eyes continuously scan the ground. Ears remain oriented in multiple directions. Foraging takes place alongside constant threat detection, because open terrain does not guarantee absolute safety. Limited food availability forces the troop to travel farther. As movement continues over time, the formation begins to stretch. At the outer edge, a juvenile slows down and drifts away from the shared control zone. The area ahead is covered with low grass that does not produce clear warning signals. There is no strong movement. There is no unusual sound. Pressed close to the ground lies a long, motionless body. Its scales blend into the color of dry grass, creating almost no contrast. Muscles remain in a ready state without movement. Distance is reduced gradually with precision and no excess motion. The strike occurs in a brief instant. The python closes its jaws and curved teeth secure the prey in place. Pulling force pins the baboon to the ground before a defensive response can form. Immediately afterward, the python coils its body and layers of muscle tighten around the target chest. Each time air is forced out, pressure increases, leaving no space for the lungs to expand. Sound breaks the silence of the savannah. The troop immediately changes direction and rushes toward the source. Distance closes quickly, but the process has already reached an irreversible stage. Heart and lung functions stop before intervention can make a difference. The presence of multiple individuals does not alter the outcome. Threat displays do not loosen the constriction. The prey remains pinned beneath the python body. After a short time, the troop begins to separate and retreat, leaving the danger zone behind. The formation is re-established, missing one individual.
On the Zambezi does not allow time for stillness. The first light reaches the ground, and the countdown begins. Not for the predator, for the prey. On this plane, the distance between survival and death is not measured in miles. It is measured in seconds. In a single misplaced step, in a single lapse of attention, prey animals move, graze, and drink, unaware that somewhere in the shadow of the tall grass behind them, a body lies flat against the earth, muscles coiled, eyes fixed on a single point. Then everything happens in under 3 seconds. This is the foundational rule of the Zambezi. No species can afford to forget it, not even for a moment. Vigilance is survival. Inattention is disappearance. And this environment does not offer a second warning. On the Zambezi plain, not every threat comes from teeth and claws. Sometimes the most consequential thing in the environment is an enormous mass of weight moving toward you. The African Cape buffalo is not a predator. It grazes, drinks, and follows the seasonal rains. But across this entire ecosystem, few species, including lions, approach a mature buffalo herd without careful calculation. Body weight exceeds 1,500 pounds. The horns curve outward and sweep upward, an anatomical structure optimized for direct frontal impact, not for aggression as a primary mode, but for making any attack against them an extremely costly decision. A buffalo herd moves slowly, not because it lacks the capacity to accelerate, but because it does not need to. The speed of an impala comes from physical vulnerability. The deliberate pace of buffalo comes from the weight of numbers. Within a herd of several hundred animals, no individual is genuinely moving alone. They function as a single unit, and every predator in the area registers that fact. When a lion or lioness closes too far, the herd does not flee. It turns. This is mobbing behavior. The largest adult males advance to the front, forming a living barrier, while the rest of the herd holds position behind. On documented occasions, the predator is the one that withdraws. Buffalo herds have been recorded pursuing lions that initiated an attack, not to hunt, but to establish a boundary. Further approach carries a cost that is not worth paying. The defensive capability of buffalo does not reside in any individual animal. It resides in the structure. In the fact that no member of the herd faces danger without the rest of the group positioned behind it. The lion is the only predator on the African savanna that operates within a stable, persistent social structure. And that structure is what separates it functionally from every other hunting species in the region. Within a pride, role distribution is not a loose arrangement. It is a functional system reinforced through daily behavior. Lionesses carry out all primary hunting activity. They coordinate using an encirclement tactic. One group drives prey forward, while another holds position at the intercept point. This is not simple instinct. It requires the ability to read terrain, read prey movement, and synchronize actions across multiple individuals. Burst speed can reach 50 miles per hour, but is only sustainable across a few hundred feet. That limitation is why ambush positioning matters more than raw speed. Male lions do not participate in hunting regularly, but their role is not passive. A pride's territory can extend from 8 square miles to more than 150, and a male's roar carries up to 5 miles. That is a territorial signal, communicating clearly to neighboring prides and to nomadic males that a boundary exists and is actively held. Males are also the last line of defense against large hyena clan incursions and against male intruders attempting a takeover from outside. When a new male assumes control of a pride, he carries out a behavior that is biologically consistent within the logic of the system, eliminating the cubs of the previous male. This returns the females to estrus sooner, allowing the new male to pass on his own genetics within the shortest possible window. This is not undirected aggressive behavior. It is a reproductive strategy that natural selection has reinforced across millions of years. During the dry season, when water sources contract and prey concentrates around the few remaining points, the lion's tactical approach shifts. Instead of coordinated open ground pursuit, they transition to sustained ambush, holding position around water sources. Waiting for prey to arrive in a state of reduced vigilance driven by thirst. The dry season does not diminish the lion's advantage. It provides a different one. Some predators hunt through speed, some hunt through strength. The Nile crocodile hunts through something no other species can compete with: time. Beneath the surface of the Zambezi, a body exceeding 16 feet in length is almost entirely invisible. Only 2 eyes and 2 nostrils extend above the waterline. And even those remain still enough to be indistinguishable from drifting debris. The crocodile does not approach prey. It waits for prey to approach. And on the Zambezi, every species must come to the water at least once each day. When the attack occurs, there is no warning. A body that has been motionless for hours releases in under 1 second, jaws closing with enough bite force. That no land prey animal has the physical capacity to resist. The animal is pulled directly into the water. An environment the crocodile controls completely and in which the prey has no functional advantage. The death roll, a continuous axial rotation carried out underwater, serves not only to kill, but to separate tissue into portions small enough to swallow. The crocodile's physiology is built for waiting. A 4-chambered heart, unusual in reptiles, allows more precise regulation of blood flow, optimizing oxygen delivery to essential organs during submersion. a specialized vascular structure called the foramen of Panizza. Coordinates blood distribution between the heart chambers, allowing the animal to remain submerged for more than an hour without measurable physiological stress. And when no prey is available for weeks or months, the crocodile does not deteriorate. Metabolic rate drops to minimum function, converting stored energy at an efficiency most vertebrates cannot reach. The water source is the convergence point for every species on the plain, and the crocodile occupies exactly that point, not through reasoning, but through 200 million years of selection pressure that placed it precisely where prey must come. No species on the Zambezi leaves a more durable imprint on the landscape than the African elephant. And none carries heavier ecological consequence without any awareness of doing so. An elephant herd operates around a matriarch. The oldest female, who holds memory of water sources, migration routes, and threats the younger members of the herd have never encountered. When drought arrives and surface water disappears, the matriarch leads the herd to locations her memory recorded decades earlier. Places where groundwater remains accessible. Elephants use their tusks and trunks to dig directly into dry riverbeds, opening temporary wells that dozens of other species, from antelope to birds, will use after the herd has moved on. The trunk is not only a water collection tool, it is a sensory organ, a social organ, and a mechanical organ simultaneously. Elephants communicate through infrasound, low-frequency sound below the range of human hearing. That travels dozens of miles through the ground surface, transmitting information about location, threat status, and the presence of other herds. During the dry season, when grass is depleted, elephants shift to consuming bark and young branches. And that process destroys more trees than are needed for nutrition alone. Viewed in isolation, this appears to be damage. Viewed across a longer ecological cycle, it is a form of regeneration, Fallen trees create light gaps that stimulate grass and shrub growth at higher density. The seeds carried in elephant dung, dispersed dozens of miles from the parent plant. Germinate in new terrain, extending the range of plant species that have no other dispersal mechanism capable of covering that distance. Elephants do not plan any of this, but the cumulative result of their daily behavior, drinking, feeding, moving, excavating, reshapes the biological geography of the entire region in ways that no other species has the capacity to replicate. No species on the Zambezi Plain addresses the problem of survival through more extreme structural adaptation than the giraffe. At close to 20 feet in height, giraffes access food sources completely out of reach for every other species. The upper acacia canopy. Where new leaf growth remains available after every ground-level browser has cleared the layers below. This is not an incidental advantage. It is the result of millions of years of ecological separation. Giraffes do not compete with other browsers because they have established a feeding tier that exists above all of them. But that height imposes a significant physiological cost. The giraffe heart measures close to 2 feet in length, one of the largest hearts of any land mammal. It must generate enough pressure to drive blood upward to the brain. Against a vertical distance of nearly 10 feet from the chest to the head. That pressure is approximately double the equivalent measurement in humans. And when the animal lowers its head to drink, a movement it cannot avoid, the entire circulatory system must manage the reverse problem. Blood that was being pumped upward is suddenly subject to additional gravitational force as it flows downward. Without a regulatory mechanism, the brain would be subjected to a damaging pressure surge within seconds. And giraffes manage this through a specialized network of blood vessels at the base of the brain. Functioning as a pressure buffer that absorbs the pulse of increased blood flow before it can cause injury. The giraffe tongue measures close to 18 inches in length, is dark purple in pigmentation to resist ultraviolet exposure. And wraps around individual thorned acacia branches with enough precision to strip leaves while avoiding the thorns entirely. This is not a learned skill. It is anatomy shaped by evolution for exactly this one function. Even their coat pattern serves a specific purpose. Under sunlight filtered through the tree canopy, the giraffe's tan and brown patch pattern breaks up the outline of the body blending into the alternating light and shadow across the savanna surface. For a predator observing from distance, the boundary between the animal and its surroundings becomes significantly less defined. Among all large predators on the African savanna, no species approaches hunting with a greater degree of controlled execution than the leopard. And no species is seen less frequently, despite being present across nearly the entire range. The rosette pattern of the coat dark rings enclosing lighter centers is not a surface feature. It is a camouflage system calibrated for light filtering through tree canopy. The alternating patches of light and shadow break up the body outline to the point where a leopard lying motionless on a branch or within low brush is effectively invisible, even at close range. Not only does prey fail to detect them, but trained observers routinely miss them as well. Leopards operate primarily after dark. The night is the environment they dominate completely. Leopard eyes function in light conditions approximately 7 times dimmer than the threshold for human vision, and their ears locate sound with enough precision to track prey in total darkness. During an approach, there is no signal, no sound, no excess movement, nothing that gives prey time to process what is happening. The strike arrives and ends before any warning can register. After a kill, the leopard does something no other predator on this plain does. It carries the carcass into a tree. A full-grown leopard can haul prey more than twice its own body weight, over 130 pounds, straight up to a branch more than 16 feet above the ground. The muscular mechanics required for that movement represent one of the highest strength-to-body weight ratios in the large cat family. The reason is straightforward. Food stored in a tree is secure. Lions cannot reach it. Hyenas cannot reach it. A carcass in the canopy is a guaranteed next meal that no other species can take. Leopards are also uncompromising in territorial competition. When a new male establishes a territory and encounters the offspring of the previous resident male, the outcome is nearly invariable. The cubs are killed. This behavior, as in lions, is a reproductive mechanism. It eliminates the reproductive investment of a rival, accelerates the point at which the female is ready to mate again, and maximizes the representation of the dominant male's genetics. In the next generation, there is no concept of cruelty built into this process. Only biological logic operating in the direction it was built to follow. Once each year, the East African savanna undergoes an event without equivalent scale anywhere in the terrestrial animal world. More than 2 million individual animals trace a circuit spanning thousands of miles, following rainfall, following grass, following a schedule written into the behavior of these species over millions of years. Zebras move first, not because they are faster or stronger than wildebeest, but because their digestive system can process the coarse, mature, fibrous grass that wildebeest cannot use efficiently. Each advance of the zebra herds effectively prepares the ground for what follows. They strip the upper layer, stimulate new shoot growth, and produce the layer of soft young grass that wildebeest require. This is unconscious nutritional stratification. Two species with no deliberate coordination, with each creating conditions the other depends on. Wildebeest follow in numbers that overwhelm the landscape. More than 1.5 million individuals forming a continuous stream that extends to the horizon. Within the wildebeest herds, reproduction is synchronized with a precision that directly affects predator pressure. More than 80% of calves are born within a 3-week window. Producing a simultaneous wave of new animals that exceeds the hunting capacity of every predator in the region. No predator can kill fast enough to shift the survival rate of that generation in any significant direction. But no point along the route is without risk. And certain points concentrate risk to a degree that makes them biological choke points. The river crossings along the migration path are the most extreme of these. Nile crocodiles gather at established crossing sites weeks before the herds arrive, holding position in the water. On the banks, leopards and lions position at known crossing locations. In the compressed chaos of thousands of animals reaching the water's edge simultaneously, predators are not the leading cause of death. The weight of the herd itself is. Hundreds of animals die each season from trampling. From being forced over steep banks, from being unable to surface against the current under the pressure of more than 1 million bodies moving in the same direction at the same time. And those animals, killed by neither tooth nor claw, feed crocodiles, vultures, and jackals. And return nutrients directly to the riverbed. Even death within this migration is a functional part of the cycle. There are environments on this planet where most species could not survive for more than a few hours. Flamingos have made exactly those environments their primary habitat, converting extreme conditions into an absolute competitive advantage. The alkaline lakes of East Africa, with pH levels reaching 10 to 12, surface temperatures exceeding 140 degrees Fahrenheit at certain points, and salt concentrations sufficient to damage the skin of most mammals, are where flamingos live. The skin of their legs is covered in thick scale layers, resistant to alkaline exposure. And their bill is one of the most structurally refined biological filtration tools among birds, curved downward at the midpoint. With internal lamellae functioning as a sieve, the bird draws water in, the tongue pumps it out, and a microscopic cyanobacteria, along with brine shrimp, are retained inside. A full-grown flamingo filters and processes dozens of liters of water through this mechanism each day. Flamingos gather in flocks that can reach 2 million individuals on a single lake, among the largest bird assemblages on Earth. That density is not social behavior alone. It is a survival strategy. Within a flock of that size, the probability that any single individual will be targeted by an eagle or hyena is extremely low. and the continuous agitation of millions of feet moving through shallow water lifts algae from the bottom to the surface, increasing food density for the entire flock. The flamingo's characteristic pink coloration is not a fixed trait. It is produced by carotenoids absorbed from the cyanobacteria they consume. An individual that feeds more efficiently absorbs more carotenoid, and its coloration becomes more saturated. During breeding season, that color intensity becomes a direct signal of individual condition. Deeper color indicates more efficient resource access, better physical state, and therefore higher value as a reproductive partner. The visual signal here is biological data. Nothing more, nothing less. Nothing on the savannah moves the way a cheetah moves when it commits to a run. And no species pays a higher biological price for that capability. The cheetah's top speed, approximately 70 miles per hour, is not the most significant figure. The acceleration is from a complete stop to nearly 60 miles per hour in under 3 seconds. The cheetah's spine functions as a compression spring. Each stride cycle releases and reloads elastic energy. From an unusually long and flexible vertebral column, producing a stride length approaching 26 feet. The claws do not retract fully as in other large cats. They function as cleats, maintaining traction through every high-speed directional change. But a body optimized for speed is a body that has traded other capacities to get there. The cheetah's skull is smaller than a leopard of comparable size. Wider nasal passages increase airflow volume. But that structural requirement reduces the surface area available for jaw muscle attachment. Bite force in the cheetah is the lowest of any large cat in Africa. It cannot hold large, strongly resisting prey through jaw strength alone. It cannot climb trees. A body built for horizontal speed does not carry the vertical climbing architecture of the leopard. After a successful hunt, there is nowhere to store the kill. The cheetah's hunting tactics are a precise reflection of these physiological boundaries. It does not ambush from cover as the leopard does. Instead, it approaches openly at a slow pace. Closing to within 200 to 300 feet before initiating the sprint. The full pursuit rarely extends beyond 1,000 feet. Because beyond that distance, the cheetah's core body temperature rises to a level that forces it to stop regardless of whether the prey has been taken. The success rate runs between 40 and 50%, higher than lions. But after each successful kill, the cheetah requires 20 to 30 minutes of recovery before it can eat. During that window, lions, hyenas, or jackals can arrive and take the kill. An outcome that occurs in approximately 12% of successful hunts. The cheetah exists at the narrow margin between peak performance and structural fragility, and nothing in its biology allows for error. In most animal species, an alarm signal carries a single meaning: danger, move. The vervet monkey does something that almost no other species on this plane can match. It does not simply signal danger, it classifies it. When a vervet detects a leopard approaching from ground level, the call it produces is a specific sequence of sounds. And the rest of the troop responds by climbing immediately, moving out of reach of a predator constrained to the ground. But when the threat comes from above, a martial eagle in a dive, the alarm call is entirely different, and the troop's response is also different. Not upward movement, but a direct look skyward to locate the attacker's angle of approach and move accordingly. For a snake, a third distinct call activates a third distinct behavior. The entire troop drops low, eyes sweeping the ground surface, locating the threat moving through the grass. Three call types, three separate responses, three escape strategies, each optimized for a predator with a completely different attack vector. This is not simple instinct. It is a communication system that carries categorical information, a minimal but highly functional form of encoded signaling. That capability makes vervets an information node within the broader ecosystem. Other species, impala, birds, certain antelope, learn to read vervet calls as environmental data. When a vervet troop goes silent without warning, the surrounding area responds in kind. Beyond communication, vervets persist because they are not specialized for any single food source. Fruit, leaves, seeds, insects, bird eggs, and small vertebrates all enter the diet depending on season and availability. That flexibility allows them to remain active through periods when more specialized species must migrate or absorb shortfalls. Within the troop's social structure, information, knowing when danger is present, which food sources are currently available, which individuals are reliable, carries a survival value comparable to food or water. An impala stands motionless in open grassland. Its ears rotate continuously, left, right, back, scanning independently for any signal the environment produces. The body is lean, muscle held under tension beneath the surface. From a distance, the animal appears calm. But nothing on this animal is actually at rest. Impala exist in a state that ecologists describe as conditional stillness, a holding pattern in which the body is preloaded for activation within fractions of a second. This is not a relaxed state. It is a continuous standby. When a threat registers, the animal does not run in a straight line. It leaps. A single impala jump can cover nearly 30 feet of horizontal distance and reach more than 10 feet of height. No predator on this plane can reliably predict that trajectory in advance. A leopard loses its angle. A wild dog loses its intercept. And in the moment of suspension between two successive jumps, the distance between predator and prey has already shifted significantly. But the jump carries a second function beyond immediate escape. When an impala launches into the open, every predator within visual range receives the same data point. This animal is physically capable. It is fast. It is not worth pursuing. This is a passive deterrent behavior, a small investment of energy that prevents a pursuit requiring many times more. It is an energy equation impala have been refining across millions of years of selection pressure. Within a herd, this strategy scales considerably. No individual is assigned a watch rotation. All animals scan simultaneously in different directions. When one individual detects a threat and jumps, the rest of the herd responds in near simultaneous reaction. No explicit signal required. No vocalization. only the movement of that single animal. A herd of impala is a distributed early warning system in which the reflexes of each individual combine into a collective response faster than any single animal could produce alone. Along the banks of the Zambezi, the space between the water surface and the tree canopy is a separate competitive zone. Smaller in scale, faster in tempo, and no less demanding. A bee-eater perches on a low branch, eyes tracking the airspace above. When a bee crosses within range, the bird launches. The catch is completed in under 1 second. But the prey cannot be consumed immediately. The bee-eater clamps the bee in its bill and strikes it repeatedly against the branch, not to kill it, but to discharge the venom sac before the toxin can cause harm. This is a purely mechanical process, neutralizing a chemical threat through physical force. After several strikes, the bee becomes a safe protein source. Bee-eaters do not operate alone. They nest in colonies along sandbanks, and their nest structures are not cavities in trees or rock faces. They are horizontal tunnels drilled directly into vertical sand walls, extending up to 18 inches into the bank. That structure insulates eggs from temperature extremes and excludes most ground-level predators. When a full colony is active, foraging efficiency increases substantially. More eyes, more directions covered, and fewer opportunities for a predator to approach undetected. Several dozen yards downstream, a flock of red-billed Quellias approaches the water. This is one of the most numerically abundant bird species on Earth. And every approach to the water's surface reflects the survival pressure that sheer numbers alone cannot eliminate. That they do not land and drink at length. They make contact with the water and leave immediately, exposure reduced to the absolute minimum. Every second of stillness at the water's edge is a second of exposure to crocodiles, raptors, and every predator species monitoring this convergence point. For the Quelea, the rule is singular. Touch the water and go. While bee-eaters and Queleas operate through speed, The heron applies the opposite strategy. It stands motionless at the water's edge for tens of minutes, sometimes longer. No muscle contracts unnecessarily. No movement occurs without function. The heron's body during the waiting phase expends almost no energy. And when a fish enters the strike window, the bill drives forward at a speed the eye cannot easily track. This is the opposite strategy from the bee eater, but it reaches the same objective. Maximize energy intake, minimize energy expenditure. Across this vast landscape, animal populations change over time. Species that expand during one period may decline during another. No species holds a dominant position permanently. Within this environment, every day presents new challenges for survival. Under the hot and dry climate of the savanna, food and water availability changes with the seasons. These fluctuations create constant pressure on all living organisms in this ecosystem. No area remains completely safe, and no moment exists when danger disappears entirely. Within this environment, the ability to adapt determines which species continue to survive and which gradually disappear from the ecosystem. Under the intense midday sun of the savanna, many movements remain difficult to detect from a distance. Within the low grass, a group of lionesses begins to move slowly. They keep their bodies close to the ground while advancing in short steps to reduce the distance between themselves and a herd of grazing zebras ahead. Weaker individuals usually receive attention first. An animal separated from the herd or moving slower than others can also become a target. Small behavioral signals from prey help predators identify possible opportunities for success. Its outcome depends on several behavioral factors. Inherited instinct shapes the initial response of animals when danger appears. The nervous system allows the body to react rapidly when conditions change. On the African savanna, every movement connects to a single objective: to continue surviving within a constantly changing environment. On the African savanna, many predator species develop very different strategies for survival. Some species depend on group strength. Others rely on ambush within tall grass. However, certain predators are built almost entirely around a single factor: speed. Among them, the cheetah provides a clear example of body specialization for short but extremely fast pursuits. When moving across the low grass of the savanna, cheetahs usually keep their bodies close to the ground. Their spotted coat breaks the outline of the body between light and grass shadow. From a distance, the body shape blends into the surrounding environment. Because of this camouflage, the cheetah can approach prey at a relatively short distance before the chase begins. When the distance becomes short enough, the hunt enters the decisive stage. The cheetah accelerates very rapidly during the first few seconds. This strong acceleration allows it to reach speeds close to 60 miles per hour for a short time. At this speed, it becomes one of the fastest animals on land. The spine of the cheetah is extremely flexible. It allows the body to extend and contract during each running stride. Semi-retractable claws increase traction with the ground during acceleration. A bite force close to 500 psi is sufficient to stop the prey from breathing and quickly end the hunt. On the savannah, this condition often turns the cheetah into a target for scavenging competitors. Lions or hyenas may appear and take the prey that has just been killed. Among the species that often appear near carcasses, the hyena is one of the most effective. Contrary to the common image of feeding only on carrion, hyenas are highly successful predators. Obviously, their bodies are built for endurance and strong bite force. Within the savanna ecosystem, water determines survival for most large animals. No land animal depends on water more clearly than the African elephant. An adult individual can drink between about 26 and 53 gallons of water each day. This volume of water supports body function and also influences how elephant herds move across the savanna. For elephants, water determines many important aspects of herd life. Movement routes often develop around areas with stable water sources. Resting locations, breeding areas, and daily activity patterns remain closely connected to water availability. For this reason, locating water is not a temporary need. It shapes the entire movement pattern of elephant herds across the savanna. The ability of elephants to locate water does not depend only on immediate environmental signals. It also depends on long-term memory built across many years. Within each herd, the most important individual is usually the matriarch. This individual is normally the oldest female in the group and the one with the greatest experience within the region. Through many dry seasons and rainy seasons, the matriarch remembers the locations of different water sources across the savanna. These memories guide the movement decisions of the entire herd. When drought continues and familiar waterholes begin to dry, elephant herds may travel distances of more than 20 miles along routes used in previous years. These movement routes often lead to areas where water still exists in limited form. These areas may include dry riverbeds, remaining marsh areas, or small water holes that have not completely dried. Elephants can reach water sources that many other species cannot locate. During the dry season, many savanna rivers leave only dry mud across the surface. However, water may still exist beneath this soil layer. Elephants can access this water through a specialized behavior. They use their front feet to break the dry soil surface. Tusks scrape deeper into the ground. The trunk removes soil and mud from the developing hole. Layer after layer of soil is removed until water begins to seep upward from below. These water holes first serve the needs of the elephant herd. After the herd moves away, they quickly become important water sources for many other savanna animals. The social structure of elephants also plays an important role in this process. A typical elephant herd contains between 8 and 20 individuals. The group mainly consists of adult females, calves, and young individuals that have not reached maturity. When males reach adulthood, many leave the herd and live alone or join small groups of males. Meanwhile, the female herd structure remains stable across many years. Within this structure, the matriarch holds the central role. This individual determines the direction of herd movement. The moment to leave an area and when to search for new water sources. When danger appears, the matriarch is also the first individual to respond and adjust the behavior of the herd. These decisions do not come from random reactions. They result from accumulated experience, long-term memory, and awareness of the surrounding environment. Through these abilities, the elephant herds move across vast savanna landscapes. And still locate the water necessary for survival during the most severe stages of the dry season. When danger appears, elephant herds change behavior very quickly. Instead of dispersing, adult individuals move to form a clear defensive structure. Larger individuals stand along the outer ring and create a protective barrier. Within this formation, the large body, tusks, and trunk function as effective defensive tools. If a predator approaches too closely, adult elephants may move forward rapidly. They use their tusks to strike and their trunks to deliver powerful blows. With their large body mass, a single charge from an elephant can force many predators to retreat. For lions, an adult elephant is almost never a typical hunting target. The large body mass and powerful counterattack ability make an attack extremely risky. However, elephant calves may become targets in rare situations. Such attacks usually occur only when a calf becomes separated from the herd or when the herd becomes scattered during movement. The influence of elephants on the savanna does not appear only during confrontations with predators. When elephant herds move across the savanna, they also modify the surrounding landscape structure. Small trees may break when elephants search for food. Dense shrubs may be pushed aside as the herd passes through. These changes gradually create open spaces within shrub areas and form new paths across the savanna. After some time, young grass often grows again within these open patches. Other herbivore species quickly begin using this new food source. For this reason, the presence of elephants influences not only their own herd, but also many other animals living in the same environment. When elephants alter the structure of vegetation, they also create new feeding conditions for smaller herbivores. However, not every herbivore on the savanna possesses the same strength and size as elephants. Many species must rely on different survival strategies. Some depend on height, to observe the environment from a distance. Some depend on speed to escape danger. Others depend on social structure and coordinated group behavior. Across the African savanna, many survival strategies exist at the same time. On the African savanna, herbivores do not rely on a single survival strategy. Each species develops specific traits to adapt to a large and high-risk environment. The giraffe is a clear example of adaptation based on body structure. Modet Dauern. It is the tallest animal living on land, with a height that can reach between 16 and 20 feet. From this height, giraffes can observe the savanna across long distances. Height also provides another advantage. Giraffes can reach food sources that are out of reach for most other herbivores. Their primary food is the leaves of acacia trees and other tall shrubs. To reach leaves among sharp thorns, giraffes use a tongue that is nearly 20 inches long. The thick tongue and tough lips allow them to pull leaves with minimal injury from thorns. However, height is not used only for feeding. When a predator approaches, but giraffes can still defend themselves effectively. They can deliver a powerful kick with the front legs. The long legs and large body mass generate very strong impact force. A precise strike can break a lion's jaw or cause severe injury. For this reason, lions usually target calves or weaker individuals. While giraffes rely on height and powerful kicks for defense. Cape buffalo rely on collective strength. This species is one of the largest and most dangerous animals on the savanna. An adult individual can weigh close to 2,000 pounds. The curved horns join at the forehead and form a thick, bony shield. This structure helps them withstand strong impacts during confrontations. Buffalo usually live in large herds. When the herd moves, calves remain in the center. Adult individuals form a protective layer along the outer edge. This structure reduces risk for weaker members of the herd. When lions attack, the buffalo herd can quickly gather into a defensive formation. In many situations, instead of scattering, buffalo turn and confront the predator. When several individuals counterattack together, lions may be forced to retreat. These situations demonstrate the strength of collective defense behavior on the savanna. Not all animals living on the grassland rely on large body size to survive. Some species develop survival strategies based on social structure and coordination within the group. Baboons provide a clear example of this strategy. They live in large troops and maintain a varied diet that includes fruit, seeds, insects, and many small animals. When moving across the savanna, the troop usually maintains a clear formation. Some individuals monitor the surrounding environment. Sentinel individuals often position themselves at elevated points or along the edge of the group. When danger is detected, they produce alarm calls. This signal spreads quickly through the troop. The remaining individuals respond almost immediately and move away before a predator approaches. On the African savanna, The landscape can change very quickly when the rainy season begins. Areas that remained dry after months of intense heat gradually turn green with new grass. When the first rains fall, the hardened soil becomes soft and grass shoots quickly grow across large areas. Within a short period of time, the dry grassland transforms into wide green fields that stretch to the horizon. The appearance of new grass creates an abundant food source for herbivores. Many animal herds begin moving toward areas that recently received rain. Wildebeest, zebras, and Thompson's gazelles often appear in large numbers across these new grasslands. Herds spread across the plains and continue moving while grazing on young grass rich in nutrients. The abundant food supply also quickly affects the reproductive cycles of many species. The rainy season is often the most favorable time for birth. When grass grows thick and food remains stable. Mothers can maintain enough energy to support newborns during the first stage of life. For this reason, many herbivore species give birth during the same period of the rainy season. Within a few weeks, the number of young animals on the savanna increases rapidly. If thousands of newborn individuals appear on the grasslands and begin moving with the herd. This synchronized birth creates an important survival advantage. When the number of newborn animals increases rapidly within a short time, predation pressure becomes distributed. Predators cannot capture all young individuals at the same time. Under these conditions, the survival rate of a large portion of the new generation increases. However, the sudden appearance of many young animals also attracts the attention of predators. Lions, hyenas, whilst conchitas often take advantage of this period to hunt easier targets. Young animals usually lack experience and respond more slowly to danger. This makes them vulnerable targets in many hunts. For this reason, the rainy season does not only bring the renewal of vegetation, it also activates many biological processes across the savanna. Abundant food leads to reproduction, the appearance of a new generation, and the rapid growth of many animal populations. However, this cycle does not continue indefinitely. After some time, rainfall begins to decline and the dry season returns. As the green grass gradually disappears, herds must move again to search for new food and water sources. Across the African savanna, life operates within the repeating cycle of rain and drought. Each phase of this cycle shapes how species survive, move, and adapt to the harsh conditions of the grassland.
The last light of the day extends across the plain. An elephant herd moves slowly toward the horizon, dust lifting lightly with each stride. At the riverbank, the water surface reflects a sky shifting through its final colors. A giraffe lowers its head to drink, then raises it and looks out across the distance. The day is ending, but the system does not stop. Somewhere in the darkness closing in, a new hunt begins. A migrating herd continues moving. A newborn calf takes its first steps on wet grass. The cycle has no defined start point and no defined terminus, only continuation. This is Africa, without gentleness, but in complete balance